Good morning, guys. My name is Trimin Bamshabi Samson. So I'm still the lead tutor for this introduction to computing 2. In our previous class, we talked about the overview. Then we talked about computer hardware, and we also talked about the peripheral and other components. And don't forget, this course has a courseware. So some of you should go and download the software so that you can read more. You can, because everything cannot be covered under this slide. So you need to download the courseware, and you can read further. So this particular section, we are diving into another area of introduction to computing 2. And in this particular section 3, I'm going to cover unit 1 and unit 2. The objective of the course still remains the same thing. It's still the same objective that we have in our section 1, section 2, and section 3. So, and I'm very sure you myself again on what that objective is all about. But this particular section 3, we are going to focus on computer software. Do you understand? We are going to be talking about computer software, which is computer software controls computer hardware. It is the software that governs the affairs of the hardware. So the program used to manipulate a computer determine how useful that particular program is. And then operating system, utility program, language translator, application software are just a few examples of various types of computer software. As a result, this course provides in-depth analysis of each type of computer software. The term software is referred to as all of the computer resources and components that are not what? Hardware, that you cannot see physically. Unlike hardware you can see, touch, and move around. But the software can't be seen physically. The only thing you can see in software is line of codes that are written in different languages. So those are the things that are visible in software. Or you will be able to see the application page, where you can now carry out the installation of such software, or you can initiate the running of that particular software by clicking on it. So those are the things that you can see in software, but seeing it physically that you can move around. You know, some software too, you understand what I'm saying, we can move them around, but not like something that we can see. We can only copy, take the CD or whatever means here to move it around. And then software. So what is software? When we say software, they were saying that software is the collection of applications that keeps a computer system running. Software is essentially a collection of applications that are operate on a computer. So it is a collection of different line of code or applications that are simply run on computer. So now the learning outcome of this course, we have mentioned, I've mentioned in my introduction there that we are going to talk about type of software, type of operating system. You understand? So type of operating system components, then type of software, application software, utility software application and user program. But we expect the students at the end of this lecture or at the end of this section to be able to do what? Understand the utility programs and application program categories. To also be able to name many categories of computer software and discuss the component of an operating system anywhere. So, I said type of software. I know many of you as a student, you might have been able to come across many software without even knowing. Or you might have come in touch with them without even knowing. So these are an opportunity for you to now know what when we say software, to be able to know that this one is for this one is for the other one. So we have type of software. This refers to the suite of software that enable the most effective that. So like I said, this refers to the suite of software that enable the most effective utilization of hardware system or offer an appropriate setting for the creation, editing, debugging, testing, and execution of user programs. An operating system is a piece of software that can serve as a conduit between computer user and its hardware. To manage computer system fairly and effectively, the operating system must choose which requests are given resources because there may be numerous potentially conflicting requests at the same time. In your CSC 101, you see we talked about programming. What makes up a program, which we said set of instructions, a line of code. So softwares like your operating system, it is the first line of software in a system. It is the operating system that communicates directly with your hardware. And apart from communicating directly with your hardware, it is the OS that allocates resources based on request and also prevents potentially conflicting requests. Because some of you might power a system now, you press power button. If you press the power button second time, you're already shutting down the system or you are putting the system to sleep. It is the software that will be able to either accept or ignore or allocate resources for the second touch of that power button. And many of you might be clicking a particular application. While the application is not responding, you continue clicking repeatedly. In order not to crash your operating system, your operating system is an intelligent software that will be able to halt such requests. And there are other requests. While you are running a system, maybe you want to run different applications at the same time. The operating system will look at which of the application is going to run faster or which of the applications that require more storage or usage space. It will be able to allocate those resources based on priority. We will do that one. We have priority, we have interrupt. You understand? An operation might be running on your system and you want to stop that operation. It is when you stop that operation in between, it is the operating system that will carry out that instruction, that will be able to send those signals to those components for them to be able to at least read those instructions, then interpret it, and then allow the system to function without interruption. So it solves numerous potentially conflict requests, and it also allocates resources to all those components. And when other application like utility software are being installed, they have to be compatible with the software, with the operating system. It is operating system that will be able to see if there's a space for such application or not, and then allow the application to run on that operating system, and then allow the application to communicate with the hard drive, because it will be able to annotate for such applications. So those are the things. And software will also be able to, it's an intelligent software that will be able to tell you that this application needs certain space size from your hardware. So if your hardware doesn't have such size, you need to first of all upgrade the hardware and upgrade the software if possible, operating system if possible. If the application requests for those two to be upgraded before it can be run. So these are things that you need to master. You need to understand that, yes, what operating system. Then in operating system, as we have rightly described, we can envision that a successful operating system will complete all of the following. Listen, as OS, it must make compiler available so that programming written in high-level language can be converted into machine languages. You get me? Maybe an OOP, object-oriented program. Do you get what I'm saying? For that application to be able to run, application written in maybe Python, R, or any other latest language, that whatever application, you must first of all install the compiler on operating system for such program to run on your computer or on your system. If an application written in Java and you have not installed JavaScript on your system, or you have not, no, I'm talking, you have not installed the Java compiler on your system, definitely that application will not run on your system. So the same thing applicable to Python and any other programming language. So they are now saying that for an effective operating system, it must ensure that make compiler available so that program written in high-level language can be converted to what? Machine language. That language that is written in whatever high-level language, it will convert it to 0 and 1 before your hardware can be able to do what? Understand what that program is all about, and they'll be able to use an effective operating system must be able to use an editor program to make it easier to create and edit program and data files. Meaning that it is still the system that you are going to use to write a particular program or to write a particular application. So an operating system must be able to provide room for editor that will allow you to create and edit program and data files. Like if I process student record and there's no opportunity for me to edit, delete data or create a new form or a new folder or a new file or a new document, it will be difficult for me to do. If I cannot do that, such operating system is not good. It's not a credible operating system. So an operating system must also what? Allow to transfer compiled program code to computer memory for execution, or a loader software should be made available. These are the work of operating system. An operating system must also offer programs that deal with complex aspects of input and output programming. It must also ensure that when a computer has a multiple processes running, each will receive equal access to central processing unit for execution. It is if I'm running CorelDRAW, running word processing, running Excel, then go ahead and run Handbrake, run playing music. The operating system must be able to do what? Allocate and give access to all these applications that I'm running, so that processor will be able to do what? Carry those things out, and then there will be a proper execution of those activities. So, and a good operating system must also ensure that, when appropriate, allow users to share system resources, and when necessary, protect them against unauthorized or malicious interferences. Before, we will have to reinstall all different utility software to do this for us. But some of the operating systems now come with firewall, come with antivirus, come with different kind of defense that can protect system and the user from losing their resources. And it also allows safe sharing of different resources when necessary. So a good operating system must also ensure when a computer has a multiple processing running, each will have what? Equal access to what? Central processing unit. I've said that one earlier. And it must also do what? Allow to manage device and storage allotment. And we should also allow for the long-term archive of users' data in form of files. So now, meaning a good operating system must be able to allow you to do what? To be able to store your file in hard drive for a longer period of time, irrespective of when you need that resources. And a good operating system is now allows system, when you slip a system and you are running 2 or 3 different applications that you don't want to shut them down. You still want, maybe after office, when you get home, you want to continue your work, and you don't want system to boot from shut down again. So you can actually slip the system. A good operating system must be able to hold those resources for a certain period of time, in as much you have a good battery. Those resources will be held at the buffer for you when you now come back to continue to use. So those are the work of a very good and flexible operating system. So that's just the simple introduction of what in a bad operating system or environment. In this scenario, the user doesn't engage with the work as it is processed. Instead, the turnaround time, the interval between when the job is submitted and when it is executed, is finished, and its findings are prepared for delivery to the person who submitted it, is the computer reaction time. That is, I don't know, maybe many of you have had the opportunity to work in a production environment before. In a production environment whereby a stack of job is being set for a particular system. I remember when I was in industrial cattle, it is set for a particular system, and they were set in batches. So once it is set, a time will be allocated for the system. At the interval of that time, it will pick up another batch and run it. That's what we are saying. That is, it will be running those systems. Maybe those systems are arranged in batches, and batches of 10. So it will take the 10 job and run them for a particular time, which is maybe 5 minutes or 3 minutes, and finish the process and forward it. The user, you just need to fold your arms, because you have already allotted time for each operations to be run. Let's say the computer need to run, that operating system need to do what? To carry out 500 jobs or 520 jobs, and he wants to run them in 10 batches. You want to run them all in 20 batch, in 20 per batch, per each batch. So he wants to run them 100 per each batch. So meaning it's going to run that job 6 times. He will first of all run the first 100 for a particular 5 minutes and deliver it at the point of exit. If you carry another 100, do it like that. Then we sell 520. Then after he has done the 500, he will carry the remaining 20. He will use similar time, maybe it's 5 minutes that is allotted for it. He might use the 5 minutes to carry out that 20 jobs. The same 5 minutes that he used in carrying out 100, depending on how the system is being programmed. That is what we mean by batch operating system, batch processing operating system, whereby the user will submit the job to a central location. You submit it to the system. Are you agreeing? Where they are compiled into batches. This is what I just explained. You submit all the 500 into the system, particularly, then they will now compile it into batches. 10, 100, 500, they will do it like that, and then place them on the inputs. Meaning the system, the job will now queue into the system. Then after the job has been queued into the system, where they will be executed in batch processing operating system environment. Do you understand me? That is where you now place it on queue. That is when it's going to now do it. You understand what I'm saying? In batches, based on the turnaround time, the allocated time for each job, at the interval of completion of certain batch, you pick the other batch, finish it, pick the other batch, finish it, pick the other batch, and deliver everything what? At the completion time. That is what we know as batch operating system. We now have time sharing operating system. What do we understand by time sharing? We said time sharing operating system offer a different way of providing computer service. In this setting, a computer offers online computing service to numerous users at once. Do you get me? Like most of the quiz that majority of you will be doing online, certain time will be what? Will be allocated, and it is expected that you guys should finish it at that particular expected time. So time sharing operating system offer a different way of providing computer service. In this setting, a computer offer online computing services to numerous users at once, like internet that we use to make it so. The internet is made available 24 hours. If I go and use WhatsApp now, I will have access to it. You will have access to it. Everybody will have access to it. Then we can I will be sending you a message. You will be sending me a message. So you will have a lot of people will have access to different operations, most especially network operating system. So most of these things are different way whereby users have access to numerous to different computer services online. So then we have the real-time operating system. As the word implies, real-time operating systems, which makes up the third class of operating system, are created to what? To support those applications where response time is crucial to prevent error and misrepresentation or even disaster. So most of the navigation system is on a real-time operating system. That is, most of this network must not work. Like your ATM, you slot in your card, you put in your input. All these things were expected to run seamlessly on what? On real-time basis, so that you will be able to do what? To have access to that resources on real-time. In a serial bank, it's not a reliable operating system. Why your money is coming in between and the money has been removed from your account. That was the kind of what we are experiencing in the early age of ATM. So a real-time operating system should do what? Should be able to do what? It is set what? In such a way that a computer offers online computing service to numerous users at what? No, I'm still talking about time sharing. That is, it's also are created to support those applications where response time is what? Is crucial to prevent error, misrepresentation. Otherwise, disaster will happen. There are systems that are being created that at least it must not even no downtime is expected. Like all this your mouse. You can see if you are going around, you can see you will see two generators there. That is called redundancy. So most of those things were in pairs in order to prevent any disaster, any shutdown. Because when one of the components shut down, the other one should peak immediately to avoid shutdown on that particular system. That is what it is called redundancy. When you build redundancy into a system, it can function in a real-time environment. That's why we say real-time operating system. Even your system now, some of the components are now they built in dual form so that at least they can also function in a real time. Not only operating systems that function in a real time. There are some components like your processor. You now have more than one processor in a system. Unlike when any age of us, like we only have single processor in one system. So it's not only operating system that function on a real time, but it's for you to just understand that in a real time operating system, are you getting it? You'll be able to differentiate to understand what batch is, what time sharing is, and at the same time, in a real time operating system, which makes up the third class of the operating system and are created to support what? To support applications that are needed to be run on real-time basis to prevent disaster. Then that takes us to multi-programming operating system. Multi-programming OS are operating systems that support many many active user programs, like portion of user program being stored in the main memory at once is known as what? Or multi-programming operating system. A computer hardware setup which multiple independent process units is known as multiprocessing system. Multiprocessing is a phrase that is typically used to describe which components, hardware, complexes that are used in important commercial or research application. What they are saying is that multi-programming operation, there are some components in your system that are pre-programmable from the factory. So some of them run on what? Some of them run on multi-programming operating system. That was why they said that it is a type of software system that supports many active user programs. Portion of programs being stored in the main memory. Do you get me? In the main what? Main memory, which is your RAM. At once is known as what? Multi-programming. So that, and it's not only in main memory alone. So we now have distributed operating system. Why rely consisting of numerous processors? A distributed operating system presents itself to its user as a conventional uniprocessor system. So if you understand what I'm trying to say there, then that's a users in a truly distributed system shouldn't be aware of where their files are stored or where their programs are running. Instead, the operating system should handle this automatically and effectively. A distributed operating system is made up of several computers that are linked together and controlled such that the workload is automatically spread across the computer that makes up the system or allocated as necessary to different processors with specific configuration. What they are trying to tell us is that a distributed system always presents itself as a uniprocessor, as if he is available without we knowing where he is. That's what they mean by a distributed system. One of it is your WW, you understand, that's the World Wide Web. What you do is that you go there, you just type this thing, then what you see it bring out the resources for you. Or you go to Google, you just type, it bring out the resources for you. What you see is the resources. Where those resources are coming from, you don't know. They are not on your system. But you just know that you send a certain address, you receive resources. You don't know where those resources are. But those resources are not resources that you installed on your system. So the user should not be aware where those resources are stored. They don't need it. It is not their business. So that's how distributed system is. And many of those things were stored. If you have been able to configure a system before, a big system for another, you will see that many of those applications were stored in multiple systems. Even your login alone, when you want to log into a particular page, whereby, let's say, your email, I want to open my email now. As soon as I click www@yahoo.com, and it brings out that initial booting or initial presentation of page can be on a different system. When you now put your login, you put your login details, then you put your password. That particular one can even be on another system entirely. That login alone can be running on a different, that application of that login alone can be running on a different system. Then when you now go into your mailbox, where you receive and send mail, that your mailbox can also be in a separate system. So, which make it very difficult for an hacker who hijack your login. You understand what I'm saying? He has to hijack your login first before he have access to your resources. You understand? So they do all those things, and it will be difficult for them to compromise. They can compromise your own account and compromise your own identity, but they will not be able to compromise the server of Yahoo, because Yahoo is having different server where you keep all those resources. Some of them can be outsourced to a different organization online. It can be outsourced to a cloud provider who offers service who offers service only, or who offer platform as a service. So different storage different storage approach. That's what makes distributed system to appear to you as a conventional uniprocessor. And all these resources are what? Are in different components, different system online. Because if you have to put all those resources on your system will crash. So it's just like that. So then that takes us to our network OS. Operating system for single processor and network are not fundamentally dissimilar, which while it is evident that they require a network interface controller, some low-level software to operate it, as well as application to enable remote login and remote file access. These additions do not alter the operating system fundamental design. Do you get me? That is, the operating system has been designed to do what? To work with network operating system and then deliver results. Before, some of these operating systems are not, you have to buy them off shelf and install them on top of your operating system. But now, you don't need that because most of those OS has been embedded on your operating system. It has now become embedded software in your operating system. Then, your system have to have network card. We call it network card. We call it NIC. You understand what I'm saying? So we call it network interface card. Then, so these are card. But now it comes with your system. It is embedded in your system. Before we have to buy it and install it on your system unit. But now it comes with your laptop. It comes with, that's why your system, when you power it, it can see, it can recognize the network operating system will come up for your system to recognize available Wi-Fi or available network provider. Depending on which of the network you want to use, once you slot in the card, then your system will be able to do to start working on it. And it's not only internet alone that network card work for. Network card also work for LAN. It work for sharing of resources through Bluetooth, through Bluetooth, through infrared, through different available sharing applications that you have on your system. So those are the things. You cannot share, you cannot transport any file without network OS. You can't transport, you can't move from one place to another, because what network is all about is the ability to communicate with another system from another location or the same location, or move from one location to another. So it is the work of network operating system to do that. So we have to understand this, because in an organization whereby you have a central printer, that should be configured in such a way with some of the network devices like your switch, in such a way that at least, or probably if it is access point, must be configured in such a way that people every other system can send resources to the printer and print from it. Because I remember when I was much in one organization like that, when we are configuring network, we will configure central printer in one system, and that system will now be shared. That particular network will now be shared, so that all the system in that organization will see the network. So once they click it, they can easily use it to print their file and go to the central system and pick up what they have sent to be printed. So just like that, you can also share resources. I can share my resources from where I am to the next person in the other room, and that person will look at it and pick it and print from there. So network operating system make all these things possible. So that takes us to one question. What are the components of an operating system? What are the components? After we have talked about type. Operating system component, which comprises of process management, memory management, secondary storage management, input and output system, file management, protection system, networking, command interpreter system, and language translator. So when we say operating system component and when we say processing management, this basic unit of system, of operating system, such as system, consists of a number of processes, some of which are user processes, which run user code, and reminder are operating system processes, which executes system code. It is possible for all of these processes to run simultaneously or concurrently, depending on what the user actually wants to, the kind of process that the operating system should be able to do that. And a good process management should be able to do the following. It should be able to allow creation and removal of system and user processes. It should be able to halt and start a new process, because when you, let's say you actually want to run a program and you click on a run program, maybe you want to at least run your WhatsApp and you went ahead and click your TikTok, you should be able to stop the running of that WhatsApp and the running of the TikTok and initiate the start of the WhatsApp applications. So every processes should be able to, the process management should allow that. And then it should also have the availability of synchronization method for processes. Processes should be able to synchronize with one another. Then it should also provide deadlock mechanism, whereby two requests or 4 requests or several requests were made at the same time, it causes deadlock. So a good operating system, a good processing operating system should be able to do what? Should be able to provide deadlock handling mechanism, which takes us to memory management. Memory management as one of the components of operating system. This particular component should be able to do at least 3 of these following. Should be able to keep track of who is currently using and which region of the memory that person is using. But when we say person, we are referring to operations. That is, which application is currently using which application is currently using the memory, and which part of the memory is it using. So it should be able to do that. Then it should be able to choose which application that needs to be loaded on the main memory, and when the free space is also available. When you say memory, we are referring to your RAM, your random access memory. Then a good memory management should also be able to assign and remove memory space as necessary. So it should be able to decongest the memory space. Then the secondary storage system. This particular component is a program which must be executed from main memory together with the data they access. The computer system must offer secondary storage as a backup for the main memory because it cannot permanently hold all data and applications. What RAM, which all our application is being run on, cannot permanently keep hold of those applications for a longer period of time. So there should be the secondary storage system should management system should be able to be available so that those data can be stored in your hard drive and free your main memory. So then, in this, the setting in which the program are run is provided by an operating system. This system is divided into manageable pieces or with a clear interface to create such a setting. A challenging task is designing a new operating system. So we should understand this. Prior to starting the design process, it is crucial to identify the system objective. Only by splitting a system as big as complicated as operating system can it be constructed. Each of these components must have a clearly defined inputs, outputs, and function as well as a part of the system. So this takes us to our inputs and output system management components. One of the purpose of operating system is to what? Is to be able to hide the peculiarity of a specific hardware devices from the user. For example, in Unix, the peculiarity of input and output devices are hidden from the bulk of operating system by the input and output system. The input and output system consists of, a buffer caching system that can keep information temporarily, a general device driver code, a driver for specific hardware devices. The devices driver know the peculiarity of a specific device. What this input and output does is that most of the peripheral devices that we have, some of them require a driver to be able to run on your operating system. But in the olden days, most of these peripheral, like printer, like your mouse, they come with their, most of them are not plug and play. So they come with their driver. But nowadays, most of those components are now embedded in operating system. So it's only on a few occasions where we have some devices that didn't come with the operating system that you now need to install that driver on your operating system. If you don't install the application driver on your operating system, definitely such component or such driver or such devices will not be able to run or compatible with your operating system. So that's why they said that input and output management system must be able to provide the following. Then we have the file management. The most popular type are magnetic tape disk, which is our hard drive, and drum. Then each of these gadgets has distinct quality and distinct physical structure. So a good file management must be what? The process of adding and removing files. The process of adding and removing files, the process of creating and deleting directories, the placement of files on a disk, the file backup on reliable non-volatile storage, so that the file can easily be, file management components should be able to allow all this set of
operations that I've just mentioned. Then protection system. Protection system is one of the components that is very important. It shifts from one, it, it's an operating system processes, which allow shifting from one action to the other. Various approaches are employed to achieve these goals, ensuring that only processes with the correct operating system authorization are permitted to access the file, memory segment, CPU, and other resources. Because if this protection system is not available, definitely there will be system breakdown. So it is embedded in operating system to allow only, to allow only processes with the correct operating system authorization will be permitted to access file, to make use of the memory segment, to make use of CPU and other resources of the system. So protection is a term used to describe a system for restricting programs, processes, or user access to the other resources specified by computer control, but will be applied together with method of enforcing those rules. So by identifying latent defeats and interconnections between components, subsystem protection can be increased reliability. Even interface error detection frequently prevents a failing subsystem from what? For contaminating a running system. Unprotected resources cannot be guided against or unauthorized or inexperienced users. So many protection systems that even opening a particular file that is not properly run or that you are not supposed, there will be a dialog box that will display why such program cannot be run or why you should stop, continue initiating the running of such application, whereby you now need to go and rectify the error before you now continue. So all these are put in place to guide against unauthorized user or inexperienced user, or to also protect file and document of the system. So if operating system doesn't have this kind of components, then there will be a serious problem. So networking, a group of processors that do not share memory or clock is referred to as distributed system. So therefore, each CPU has its own local memory, and the processor talks to one another via a variety of communication connections, including high-speed buses and phone line. Distributed system comes in all shapes and sizes: microprocessor, workstations, mini computer, and massive general purpose computer system might be used in them. What they are now telling you that apart from physical networking that you know that you maybe wired network or through wireless, there is also communication going on inside the system that require networking. How the processor communicates with hard drive, how the hard drive communicates with the RAM, then other peripheral and other components in the system. It is through communication, and anything that can communicate with one another is networking. So it's very important we know this, that If an operating system doesn't have network management system in place, such such will be very dangerous for an operating system. So then we have command interpreter. The command interpreter is one of the operating system most crucial part. The main point of contact between the user and the rest of the system is the command interpreter. Control system can use the operating system in a variety of commands. A program that reads and understands control system is automatically run when a number of jobs is started. It's a batch system, or when a user comes in to use time shared system. The control card interpreter, command line interpreter, like shell in Unix, you understand, like command prompts in Windows, have all been used to refer to this program. Then get so this is very, very important. Then we have language translator. It's a program language. It's a set of symbols that we use to communicate with computer in the early stage of computer development. Machine language program use the binary, which is 0 and 1. We've done this in our 101. You understand? So other computer languages were created to try to address these issues. Computer can only execute programs written in machine language, though therefore program development in this other language must be converted to machine code. So if you are asked what is language translator, all of you know it. We did it in a language translator is a software tool or a program that converts text or code written in one programming or natural language into another, like your C++, C#, C, Python, R, COBOL, Perl, Java, many other languages like that. So that takes us to, that is what I expect you to all know when we are talking about language translator, which comprises of our assembly, interpreter, then our compiler construction. So that's just it. And I've said it that an assembler cannot be transferred. An interpreter, you read the program line by line, while the compiler read all the program at once, then and run the code and interpret it. So that's just it. So like I said language translator, at least I've defined it for you. So and I said assembler. A programming language is a set of symbols that we use to communicate with computer. In the early stage of computer development, and then I've mentioned that yes, binary is the only thing that computer recognizes, which is 0 and 1. So before we now have other languages that need to be converted to machine language before they can be used. So when we now say, that takes us to what are the classes of those translators: assembler, interpreter, and compiler. We have dealt with this one in our CS 101, and I don't think I should now be repeating myself, but I can, for the sake of understanding, I can as well go over it again. Like I said, an assembler is a computer program that receives an assembly language. Such program and read and convert the complete program into an object program or object code equivalent in machine language. Since each machine has its own assembly language, one machine language cannot be used on another system. Meaning that every device comes with its own assembly language. And what an assembly language does is to read a source program, read all the source program at once, and convert the complete program into an object program or object code, which is equivalent to what? Machine language. And you cannot have two assembly language. What it does, it takes that source code, read it and convert all into what? Object code or machine language. While an interpreter, a program known as an interpreter, receives programs written in other languages, read them, translate them into machine code, but it will do it during the execution. It will not do it line by line. But and listen again. It will receive a source code. It will receive a source code. It will read it. It will read the entire source code. Then it will translate them. Then in the execution stage, it will execute them line by line. While a compiler takes a source code written in high-level languages, written in COBOL, written in Perl, written in C, written in C#, written in R, written in Python. Are you doing? It will read all and converts all into an object program, which is machine, or object code that is written in machine language. To convert everything. Why? During that conversion, if it meets error, it will debug that error and return error for the programmer to correct that error before it can now run it. I hope I'm communicating with you. So this translator now have their own, the compiler now have comparison stage now include lexical analysis, syntax analysis, semantic analysis, and code generation, which is quite several various compilers available for high-level language. So some of them, we have COBOL, Fortran, Basic, and Python, Java, R, and several other languages. Do you get what I'm saying? C# and the rest. .NET. But all of them have their compiler that works for them. So that is one thing you need to know. Compiler running on one machine can run with little modification on another. You can take a compiler and go and put it on another system, it will run. No, you can't do that with assembly language. You understand? Because each system comes with its own assembly language. So you cannot transfer assembly language, but you can transfer compiler. And what the interpreter does is that he takes program, he reads it line by line, and executed them line by line. So that one will take a lot of time compared to compiler who will read everything and then carry out those instruction once. So in a system now, in an operating system, are you with me? They were trying to tell us how in a system level, they are trying to explain system level to us, how it is. Operating system is the midwife. Is the midwife between the hardware and the application program. because application program is installed on the operating system. Without the operating system, application program cannot function. So application operating system needs to stand between, is the midwife. So all other applications that you want to install, be Microsoft Word packages, be CorelDRAW, your WhatsApp, your Facebook, your browsers, you are installing them on the operating system, and those applications will communicate with all this hard drive through the operating system. They will make their requests, they will do every operations through the operating. It's the operating system that will now send those through the operating system. Now all these hardware, your system units cover your hardware, your printer, your keyboard, all these peripheral, your monitor, your drivers, then your RAM. So everything will be communicating together. So this brings us to the end of Unit 1 in Section 3. Then in Unit 2, in Section. So this is where we talked about utility software. We have talked extensively about operating software, which is OS, operating system. Now we want to talk about utility software. This is a set of commonly used programs in data processing department, also called service or general purpose program. They perform the following operations: file conversions, file copy, housekeeping operations. So these are. Then when you are not saying file conversion, this includes copying data exactly or simultaneously editing and verifying them, verifying it on any medium. So file copy from one medium to another, from one portion of medium to another portion. Housekeeping operation include tools for labeling files, cleaning up storage space, and updating shared data. So utility software is more than that, because we have several utility software. We have several utility software that are more than that. So, but let's just, for the sake of these lectures, let's limit it to all they have said. Then we go to application software. Application software. It's a collection of applications made to address a particular type of issue. It might be provided by the computer maker, or in some situations, user might create their own application programs or user programs on their own. Thus, generalized software and user-defined software can be used to further separate application software in various types. Then there are lists of application software. I've explained this one. There are lists of them: word processor, spreadsheets, integrated package, graphics, database, statistics package, desktop publishing, game, communication. So these are several. There are several of them that we need to know this, so that it will help us. Like the word processing, I said word processor is used to create, edit, save, and print reports. Like we all know Word. You use spreadsheet too. You know what spreadsheet is used for. You understand? Numerical figure and reports. So these are things that it is being used for. Then we have integrated package. So that is just it. Then we have graphic package, like we have said, CorelDRAW and the rest of them. So different operating systems have different desktop publishing And we have application packages. This is a collection of applications created by programmers or users of computer. They are necessary for accomplishment of their particular job or businesses. A payroll package is created for specific company, salary operations, like one packages that we just did recently for anything. I don't know, well, it's beyond this class, so it's not something but just know that all these things are very, very essential, and as it has been explained in other sections. So you just read more about all these things so that at least you can get yourself familiar with them. Now, this takes us to our pilot questions, but which it will be set for you in your LMS. So I think with this, we have completed this section, and with this section now you can at least be able to do what? To do a lot of things. Then I will be able to continue from the other section. So in summary, what we have done today is operating system as the executive manager of the computer type of operating systems and function of the operating system. Language interpreter, compiler, assemblers are examples of language translators. Utilities like ScanDisk and tool for copying and converting files as well as housekeeping app. And then software application include word processing, spreadsheet, and statistical analytical tools. Then that thought on our key self-assessment questions, try as much as possible to see what you can. Then thanks. With this, we have come to the end of the class today. And thanks for listening.